About signs. These things do have signs associated with them, and we have mentioned that a number of times. By signs, I mean actually directions, right? Up, down, left, right. Plus, minus, right? Plus and minus on a coordinate axis indicate whether you're going to the right of 0 or to the left of 0. I'm going to go back a couple pages and look at these equations. Delta x, v average, v, a average, a, distance and speed. And ask the question, which of these variables have a direction associated with them? In other words, does distance have a direction associated with it? I'm looking on the right hand side, on the right column. Does speed have a direction associated with it? Displacement, velocity, and acceleration. Let's just lump average velocity and instantaneous velocity, average acceleration, instantaneous acceleration. Do they have directions associated with them? And if they have a direction associated with them, what does positive and negative mean, or how do we indicate the direction? So directions and directions of quantities, I guess. But before I get to this, I've actually got to go for a run, so I'm going to have a break, and I'll give you a joke before I go. A grasshopper walks in a bar, and the bartender says, "Hey, we have a drink named after you." The grasshopper looks surprised and asks, "You have a drink named Steve?" Bye-bye. Okay, so looking at these quantities, which of them have directions associated with them, right? Position or displacement has a direction associated with it because it's relative to an origin, right? What is my position in the room, or how far have I displaced? I've either displaced away from the origin or towards the origin. And so if I'm going away from the origin, then my position, if I'm going in the positive direction, then my direction is the positive direction. If I'm going in the negative direction, then my direction is the negative direction. And so position and displacement have a direction associated with it. I'm going left or right along the coordinate axis, or up and down if my coordinate axis is up and down. So therefore, velocity must also have a direction associated with it, because velocity is dependent on position. And acceleration must have a direction associated with it, because acceleration is dependent on velocity. But it also makes sense if I'm talking about I'm going 55 miles an hour east, 55 miles an hour north, south, whatever. I'm going 55 miles an hour to the left. So velocity, acceleration, and position and displacement all have directions associated with them. These are called vector quantities, right? They're vector quantities. What is a vector? A vector is something that has a magnitude and direction. Vector quantities. In one-dimensional motion, we're just talking about an x-axis, right? So if I'm talking about moving along the x-axis, this is my x-axis plus x, this is my x-axis minus x. And if I'm moving to the right, I'm moving in the positive direction. If I'm moving to the left, I'm moving in the negative direction. Okay, even if I'm moving to the left in the positive region of the x-axis, I'm moving in the negative direction, because by displacement, x final minus x initial, if I'm moving to the left, then x final is going to be smaller than x initial, so therefore this whole thing is going to be less than 0. So moving to the left on this x-axis is negative, moving to right is positive. So the displacement or the position can be denoted with a plus or a minus, and that plus or minus indicates direction. So these are vector quantities. That means velocity, if I'm moving to the right, is positive. If I'm moving to the left, is negative, because velocity is displacement over time. So if the displacement's positive, then the velocity is positive. If the displacement's negative, the velocity is negative. Acceleration has to do with how the velocity changes. If the change in velocity is positive, then the acceleration is positive. If the change in velocity is negative, the acceleration is negative. We'll come back to that in a second. What I want to do is point out that these are vector quantities, and vector quantities by definition have a magnitude, a size, and a direction. Direction can be indicated as things like plus and minus, or right and left, etc., right? Up, down, etc. Okay. There are some quantities that we measure that don't have direction associated with them. and they are called scalar quantities. These, the ones on the right column, are scalar quantities. Oops, let me be careful here. Scalar quantities are quantities that have a size but don't have a direction associated with them. So distance, right? If I've gone 5 miles, right, it's a curvy path, I can't really say what direction I've gone. Distance is just path length traveled. It doesn't have a direction associated with it. Speed, in addition, because it's distance over time, speed does not have a direction associated with it. Time doesn't really have a direction associated with it. It's something which is a little hard to say, because we really, time goes forwards or backwards, so it theoretically does have a direction associated with it, but we treat it like a scalar in physics because it's always just one-dimensional. Time is just one-dimensional. And so we generally, while elapsed time can be positive or negative, it's still treated like a scalar. There are other vector and scalar quantities in physics, right? Or in science. You just think of any quantity you could possibly measure. For example, force. Force is something which we'll figure out, we'll learn later if you don't already know. Force equals mass times acceleration. So since acceleration is has a direction associated with it, then force does too, and force has a direction, right? When we talk about a force, if I talk about how hard or if I talk about what is the force that one football player exerted on another football player when he was tackled, the force, it has both a magnitude, but it also has a direction. The force was downfield, or the force was upfield, right? The tackle was downfield, the tackle was upfield. There are, so every quantity you can think of is either a scalar or a vector, and you need to think, how is that quantity defined, or how do we use that quantity? Sometimes it's easier to think to determine whether it has a direction associated with it or not. For example, temperature. Is temperature a scalar or a vector? Does temperature have a direction associated with it or not? The answer is no, right? We never talk about what is the temperature up or what is the temperature down, right? I mean, that doesn't make any sense. Temperature has just a quantity associated with it. So temperature is a scalar. And then, I don't know, think of something else. Power. Power is energy over time. Oh, energy, right? Time isn't a scalar, so is energy a scalar or a vector? Energy has a value, right? I've got the food has, an ice cream sandwich has 200 calories, right? It doesn't have 200 calories to the left or 200 calories to the right. It's just got 200 calories. So energy is a scalar. It's not defined in terms of vectors. Actually, energy, if you look at the definition of energy, or let's say kinetic energy, which is something which you may not know yet, is defined in terms of speed. So if you can look at their definitions, right, if things are defined in terms of distance, speed, or time, then they're scalars. If they're defined in terms of displacement, velocity, or acceleration, then they're vectors. So the signs of vectors are very important. So we haven't been careful about it because we're just talking one-dimensional motion. But even in one-dimensional motion, the signs are important. It depends whether I'm moving in the plus x direction or the minus x direction. In one dimension, we're going to stick with the x direction as our dimension. And the signs are important. And so now from now on, I'll be very explicit about talking about the signs of vector quantities, even if it's obviously positive. Because it's a vector, I'm always going to put a plus or a negative in front of it. If it's not a vector, then I'm not, right? So the plus or minus determine direction. They have nothing to do with the value of the scalar. Like, for example, what I mean by that is, let's say I say I've got a velocity of plus 55 miles an hour. Or I've got a second car has a velocity, a car has a velocity of 55 miles an hour. We have a second car, let's say it's a red car, has a velocity, or it's a car with red writing, of negative 43 miles an hour. Okay? Actually, that was a bad example. Hold on. Okay, so let's say I have a blue car that's going at positive 55 miles an hour and a red car that's going at negative 55 miles an hour. Which car is going faster? Neither car is going faster. They're both going the same speed. They're going the same speed, right? They're both going 55 miles an hour, but they're going, what is the minus sign versus the plus sign? They're going in opposite directions, right? One is going in the plus x direction, the other is going in the minus x direction. So neither car is going faster than the other. Ooh, this does bring up a really important point, which I'm using this quantity speed here, which is different than average speed. We should talk about what speed is before I go any further. Okay, so remember that average speed, just said this a million times now, is distance over elapsed time, elapsed time. And I've been using the quantity speed, which I neglected to define. Speed has nothing to do with average speed. That's important for you to recognize, is that speed is equal to the magnitude of the velocity. Magnitude of velocity, right? So the velocity, remember, is equal to dx dt, or the slope of the position versus time graph. It's equal to delta x over delta t if only for constant velocity. I'm just writing that delta x over delta t so we don't have to worry about derivatives for those of you who are not so comfortable with those. Delta x over delta t. But the average velocity is a vector, right? Delta x has a direction associated with it, right? So it's like 30 miles per hour east. The magnitude of that vector is 30 miles per hour. The magnitude of a vector, is also written as the absolute value of the vector. And later on, we're going to start using the vector sign. We're going to start putting an arrow on top of these things to indicate that they're vectors. Right now, not so important, but I'll probably start doing it. We didn't do it before because in one dimension, the vector really indicates just positive or negative, and so we don't need a vector sign so much to indicate. But once we move into 2 and 3 dimensions, we use the vector sign. In any case, the magnitude of vector is the absolute value of it, and it is just the size of that vector without direction, so 30 miles per hour. So that is the magnitude of a vector. So the magnitude of the velocity is the speed. Magnitude. I guess I had already written that. I wrote that twice. But anyway, this average speed, notice, distance over time, has little to do with the displacement over time. And the magnitude of the displacement over time is the speed. So the two, speed and average speed is not the average of the speeds or anything like that. These two are different quantities. Okay. So I was talking about the vector natures of these quantities and how a positive velocity is no faster or slower than a negative velocity, because the positive and negative sign in vector quantities indicate direction, don't indicate how big or small something is. So when we're talking about vector quantities such as velocity, displacement, and acceleration, positive or negative signs indicate direction, not how big it is. As opposed to let's take a scalar quantity such as temperature. Right? So if I have a temperature, if on one winter day the temperature is plus 33 degrees Fahrenheit, and then on another winter day, let's say a second winter day, it's minus 33 degrees Fahrenheit, which day is colder? Well, the T2 is colder than T1, right? Negative 33 degrees Fahrenheit is colder than positive 33 degrees Fahrenheit because negative 33 is smaller than positive 33. That negative has nothing to do with direction. It has to do with the size of the quantity. And again, that's true only for scalars, not for vectors. For vectors, negative and positive signs only indicate direction. For scalars, it indicates size. Okay, so the last thing about direction is, again, when we're